everyone. In this video, I'm going to be going over how to do ideal gas law calculations. So you can be on page 11 in your packet of fun. So first off, the ideal gas law is basically if you're given one set of conditions, you can use this law to predict what a missing variable would be. So if you notice in the center of the page, this only works when a gas experiences one set of conditions. So a lot of times there's confusion about when to use the combined gas law versus the ideal gas law. Well, for the ideal gas law, it's only one set of conditions. So the formula for this, or the equation that we're going to use for this, a lot of times you'll hear chemistry teachers say PIVNERT. And basically what that means is PV equals nRT, PIVNERT. And that is the formula for the ideal gas law. And let me explain a couple things. So you should already know what P stands for. P does stand for pressure. V stands for volume. N is still number of moles. T is still temperature. R is the new guy. R represents a constant. R is a constant, and there's lots of different numbers depending on the units that we're going to be, or that scientists use when they're, the units for pressure, when they're doing or using the ideal gas law. But for us, these are really the two R constants that we are going to use. And something to note about this, we are going to use 8.314 if our pressure is in kPa. And we will use 0.0821 if our pressure is in atmospheres. Okay, if I give you any other pressure, like millimeters of mercury or torr, you do need to convert it to one of these two in order to use R as 0.0821 or R as 8.314. So just keep that in mind. We're going to work through a couple of these together. So in example 1, it says how many moles, so they're asking for N. How many moles of argon are there in 20 liters, that's volume because liters is a unit for volume, at 25 degrees Celsius. Celsius is temperature, but it does need to be in Kelvin, so 25 plus 273, and that is 298 in Kelvin. And then 96.8 kPa, that is going to be a pressure. Now, unlike the combined gas law, we saw two of at least one of the letters. For this, we see an N, a V, and a P that we've labeled. So that they're asking for moles. They gave us volume. They gave us temperature. They gave us pressure. This is one set of conditions. When you notice that there's only one set of conditions, that's when you know you're going to be using PV equals nRT. And at this point, you can just plug the numbers in and then solve for the missing variable. So I will do that with you. So the pressure in this one is 96.8. And we multiply that by our V, or our volume, which was 20 liters. And that is set equal to N, which is number of moles. So I'll just put an N there for now, or you could put an X there. Times our constant, so our R, our R value. So for the constant, we do want to take note that in this particular problem, we are in kPa. So the constant that we want to use is going to be the one that has the unit kPa in it. So it's this R equals 8.314. So we're going to use 8.314 as our constant. And then we're going to multiply that by the temperature, which is 298. And then here we can begin to solve. So if we do 96.8 times 20, that gives us 1936, and that's equal to 8.314 times 298. Whoa, that's a big number. And it's 2,477.572, and I'm just going to throw an X at the end there. Actually, I'll just keep it standard. I'll keep the N. And at this point, we just solve for N, so we have to divide by that really big number. So it's 1936 divided by 2,477.572, and that equals, or N equals 0.78, and that's number of moles, so we can just put unit mole at the end there. And that is it for that one. Example 2. It says a sample of CO2 has a mass, tricky, a mass of 35 grams. That's an interesting little tricky thing I threw at you guys. So if I give you mass, that number we can use to convert to mole so that we get our N value. And it occupies 2.5 liters at 400 Kelvin. What pressure does the gas exert? And I do have a note for myself to use kPa for this one, even though I forgot to put it on your page. Use kPa as your unit for pressure. So we do see one set of conditions. So we're going to be using PV equals nRT. And we can start plugging our numbers in. So we are solving for P, so I'm just going to leave it blank for now, and I'll put a P in after I write the volume. So the volume that we're starting with is 2.5, and I'll just put a P there. And that is equal to N, which is our number of moles. But the thing is that I gave you grams, so I was being tricky. And so what we are going to do is we're going to convert 35 grams, and the substance was CO2. And we're going to convert that to moles, and then we'll have our N. So whatever unit we start with goes in the bottom, grams of CO2, and 1 mole of CO2 goes up top. And, okay, so carbon is 12 plus 32 for the 2 oxygens. 16 times 2 plus 12. The molar mass of CO2 is 44. If you wanted to be super precise, it's 44.01. So we just divide these out. 35 divided by 44, and that is 0.795. Then we're going to take that number, then we're going to use it for N. So 0.795. And then next up is our R value. Since I did specify at the beginning to use kPa, we're going to use 8.314. Then the last variable that needs in is temperature. And the temperature in this one was 400. And now we solve. So we see here 2.5p is equal to, and we'll calculate this, we'll do 0.795 times 8.314 times 400, and that is 2,000 643.852. And then we want to isolate our variable. The way we do it is we divide that number by 2.5. And then our pressure is around 1,058. 1,058, and we were using kilopascals. And that is the answer for this one. So again, just as a reminder, PV equals nRT is the equation that we use for the ideal gas law, where R is the constant, dependent on what units of pressure we're going to be using. So keep that in mind as you're determining what R value you're going to plug into your calculations. And it's a simple algebra problem, so you're going to be solving for the missing variable. Make sure that your temperatures are in Kelvin.